Good afternoon, everyone. You're now watching the TanyaCikgu program live from our studio. I'm Miss Christina, and today I'll be with you for the next 2 hours to answer questions on the subject of chemistry. So I know a lot of you just finished your trials, and I think you have a lot of questions about your trial exams. Okay, so the first question is from Justin. Justin is asking about cell 1 and cell 2. Okay, so this is actually a very common question where they will give you two kinds of apparatus to compare. Okay, so basically one is with carbon electrodes. Okay, one is with carbon electrodes and the other one is with copper electrodes. Okay, so the solutions, usually they use copper 2 sulfate, but in this question's case, they use copper 2 nitrate. All right, and they give you, the carbons are called T, U, and the coppers are called V and W. All right, so the question is the meaning of an electrolyte. So the electrolyte is an aqueous solution in an ion form that has free moving ions that can conduct electricity. Or you can write there the solution, aqueous solution or molten that is decomposed during electrolysis. Okay? State all the anions present. So because it's an aqueous solution, you have to write down that, question B, it has nitrate ions and it also has hydroxide ions. They're asking you about anions. Okay? Based on cell 1 in diagram 4, write the half equation for the reaction at T. So, okay, this is what happens. This is positive, this is negative, this is positive, this is negative. For the negative electrode, right, for the negative electrode, it's always the same. Copper ion is always chosen to be discharged to form copper. So for the cathode, it's the same for both. Okay, the only one is different is the anode. The anode is different for T and for V. For T, you are using copper. So the ion that will be discharged is hydroxide. So hydroxide will be discharged to form water, oxygen, and electrons. For V, it's made out of copper. So it is a reactive metal. So the copper itself will react to form copper ions. Okay? So this question is asking for T, so this one is T. All right? Can I have the next question? Okay, so questions like this, they usually ask you color change, they ask you anode and cathode. All right? So let's look at question 2 from Faiz. Diagram 8.2 shows the apparatus set up to study the transfer of electrons and distance between bromine water and iron 2 chloride. Okay, so this kind of question, always remember, okay, I know it's a big mistake for you all to think that the reaction is between bromine and chlorine. It's not chlorine. The question says iron 2 chloride. In iron 2 chloride, this is iron 2 plus. So whenever you see Fe2 plus, Fe2 plus only knows how to become Fe3 plus and it will release an electron. So the electron will go this way, and bromine really likes to hold electrons. Now, some of you ask me, then teacher, what about the chloride? Here is FeCl2, the chloride here is an ion. It already has the electron. It's very happy. It's not going to react anymore. So the reaction happens between iron 2 and bromine, not the chloride ion. Now, chlorine is very reactive. Chloride is very happy. It won't react anymore. Okay, so you have to know that when it's FeCl2, it's not Cl2, it's Cl negative ion. Okay, so direction of the electron flow is this way from iron 2 chloride to bromine. And describe the redox reaction. So when you describe the redox reaction, you have to mention For iron 2 chloride, iron 2 ion loses the electron, and then this is oxidation. So you explain this is oxidation. Okay, then bromine receives electron, and this is reduction. Okay, and then you talk about the color change. All right, the color change, iron 2 is green, and it changes to iron 3, which is brown. Okay, and then over here, bromine, which is brown, changes to colorless. All right, so this question is 10 marks. So how do you get the 10 marks? So 1 mark is the equation for each 1, 2. Okay, 1 mark is for oxidation and reduction, 3, 4. All right, then you talk about the electron flow from iron 2 chloride through the wire external circuit to bromine. Okay, and you talk about it deflecting. Okay, and then you talk about the color change. So that's it. That's your whole redox. All right. Okay, so this kind of question, okay, this kind of question is always the same, regardless whether they ask you like this or they ask you like this. It's the same. Do not confuse this. This, remember, is chloride, not chlorine. Okay, can I have the next question? All right, you can also mention in this essay that this is oxidation and reduction. That's why it's called redox. Okay, now for this kind of question, they can shift around the chemicals. Instead of using Fe2+, okay, they can actually make it more complicated and put here FeCl2 and then here put Cl2. Okay, put chlorine water. Wow. So if you are a student doing this question, you're going to be so confused because everything looks the same, right? So what happens is, again, you have to know that this Fe, Fe2+, becomes Fe3+. Okay, and this is chloride. This will become chlorine. Okay, now what else can we do? What else can we change? So we can also change it to potassium iodide. In terms of potassium iodide, iodide is the one that will release the electron. Okay, iodide is the one that released the electron. And over here, you can also have bromine receiving the electron. Okay, so you can swap this to anything. Always be very clear about what kind of chemical is there. All right. Okay, third question. Table 8 shows the thermochemical equation of experiment 1 and experiment 2. So experiment 1 is sodium hydroxide with hydrochloric acid. You get sodium chloride and water. So this is heat of neutralization is negative 57.3 kilojoules per mole. All right, and experiment 2 is the same thing, except this time you're using a weak acid, ethanoic acid. So you get sodium ethanoate and water. And the heat of neutralization is less. Okay. State the type of reaction. So the type of reaction, you can say exothermic. You can also say neutralization. All right. Explain the difference of heat of neutralization for the experiment 1 and experiment 2. Okay, now here's where you need to know what is the definition. The definition of neutralization is when 1 mole of water is formed from the neutralization of acid and alkali, you will get heat of neutralization, and that is always 57.3 kilojoules of energy released. Okay, so that is heat of neutralization. Then how come it's less when you use ethanoic acid? So your first mark is always to say that hydrochloric acid is a strong acid. Okay, ionizes completely in water. Okay, ethanoic acid, so just the other way around, is a weak acid, and therefore it ionizes partially in water. Now, because it ionizes partially, here's the part that you have to understand. When it ionizes, it forms CH3 COOH ion. When hydrochloric acid ionizes, it also forms the same thing. When you add alkali to neutralize it, you are adding NaOH. For neutralization, the OH ion is the one that reacts. Okay? OH ion will react with hydrogen ion to form water. OH ion reacts with hydrogen ion to form water. When 1 mole of water is released, how much energy is released? 1 mole of water is always 57.3 kilojoules. Over here for weak acid, is it also water? Yes, it's also water. Do you also get 57.3 kilojoules? Yes, you also get 57.3 kilojoules. But then, how come it's only 51.1? What happened to the remaining 6 kilojoules? Where did it go? Okay, so we think about it this way. It's as if your mom asked you to make 100 cookies. You have enough ingredients to make 100 cookies. In the oven, you put in 100 cookies. And when you are packing it into bottles, okay, in the oven there was 100 cookies, okay, but when you are packing it into bottles, and finally when your mother came to check, there were only 97 cookies. What happened to the other 3? So you ate them, right? Obviously. The same thing happened here. Who ate it? The molecules. The molecules of ethanoic acid want to separate to form hydrogen ions. After this has reacted, it releases 57.3 kilojoules of energy. Some of the energy needs to be absorbed again. You need to absorb some again. You need to eat some back in order for them to have energy to make more ions. It's the same thing. You made 50 cookies. You ate 3 of them so that you have more energy to make another 50 cookies. Okay? So you release so much energy. You release 57.3 kilojoules, but you absorb some so that your ethanoic acid molecules can ionize. Okay, how do you write that in words? Obviously, you can't say cookies in your exam, right? So the first thing you say is ethanoic acid is a weak acid. It ionizes partially in water. So during neutralization, so this is a very common question, okay? So during neutralization, some heat release is absorbed. Okay, who is it absorbed? It is absorbed by ethanoic acid molecules. It is absorbed by the ethanoic acid molecules. Why do the ethanoic acid molecules want to absorb the heat? To ionize ethanoic acid molecules. Okay, Because when they ionize, they can make more hydrogen ions, and then the hydrogen ions can react again. All right? Okay. The second part of the question is calculation. In experiment 1, 50 centimeter cube of sodium hydroxide is reacted with 50 centimeter cube of hydrochloric acid. Calculate the heat release. All right. So this kind of question, you always do the same thing. Okay. So you calculate first the amount of moles. The amount of moles is mv over 1000. So your m, molarity is 1. So you get 0.05. Okay. Now, after that, this is the amount of moles of water. The amount of moles of acid is the same amount of moles of water. 1 mole of water produces 57.3 kilojoules of energy. Now you got 0.05 moles of water. How much energy is released? So you calculate the heat release is 0.05 times 57.3. So you get 2.865. Okay, now here's the part that is very important. Units. This is in kilojoule. This is in kilojoule. Every time you get something in kilojoule, change it to joule. 2865 joule. Okay, so step 1, calculate the moles. Step 2, calculate the heat that is released. Now the question is asking you to calculate the heat release. Okay, and then the next question is usually asking you to calculate the energy, the temperature increase. Okay, so if they're asking you to calculate the temperature increase, here we already have heat. Okay, but if they're asking you to calculate temperature increase, remember, heat is mc theta. So heat is 2865 kilojoules. M is the volume of water that is given. The total volume of acid plus alkali. Okay, C is 4.2. It's always given in the question. And theta is what you're calculating. All right. So temperature increase will be divide 100 and divide another 4.2. So about 6.82 degrees Celsius. Okay. Can we have the next question? All right. So next question. This one is empirical formula. So empirical formula, you are given carbon, hydrogen, oxygen. Okay. Okay, don't draw it so ugly in exam, okay? Exam, please draw a nice table. Okay, so you divide the molar mass. 16, divide 1, divide 12. Okay, so 37.5 divided by 12 equals to 3.125. This one is 12.5. 3.125. Okay, and then you divide the smallest number. So all three of this, 3.125 is the smallest number. So you get a ratio of 1, 1, and 12 divide 3.125, 12.5 divide 3.125, you get 4. So the ratio is C1H4. Oh, C1H4. A lah. The answer is A. Okay, can? Alright, so remember, after you get the ratio, you divide the smallest number. So this is the smallest number. Alright, so it's basically taking 3.125 divide 3.125, 12.4 divide 3.125, 3.125 divide 3.125. To get the smallest ratio. Alright? Okay. Can I have a next question? Oh, sorry. Teacher, please jawab bahasa. Okay. So sorry. I didn't see that. Alright. So, Afiq. So, untuk kira formula empirik, kamu kena ambil jisim yang diberi. Okay. Bahagikan dengan jisim atom relatif. So, bahagi 12, hidrogen bahagi 1, oksigen bahagi 16. Kemudian, kamu dapat nisbah bilangan mol. Tapi tak boleh guna nisbah ini. Kamu mesti dapatkan nisbah paling kecil. nisbah paling kecil kamu bahagikan dengan nombor yang paling kecil. So nisbah bilangan mol yang kamu dapatkan 3.125, 12.5, 3.125. So kamu bahagikan semua dengan 3.125 untuk dapatkan nisbah paling kecil 141. Okay, so soalan tanya formula empirik. Alright? Okay, can we have the next question? Color test. Color test for what? Aisha, can you be a bit more clear? Are you talking about color test for salts or color test for... okay, so while we're waiting for Aisha, okay, can I have a next question? Okay, so wait for Aisha. Aisha, you tell me what color test you want, okay? A titration between acid sulfuric acid and sodium hydroxide solution using phenolphthalein as an indicator. Write a chemical equation for that reaction. Okay, when they say indicator, your indicator doesn't have to be part of the equation. Okay, it looks like they're asking you to write with the indicator, but you don't need. So, sulfuric acid and sodium hydroxide. So you get sodium sulfate and water. Yeah. Okay, so you don't need to put the indicator in the equation. Question 2, draw a diagram of a titration between sulfuric acid and sodium hydroxide. Okay, so I try and make it as pretty as possible, okay? So please use a ruler and pencil during your drawing. So this is your burette. And here you have sulfuric acid. And here you put your alkali, because your indicator has to be put inside your phenolphthalein. Your phenolphthalein has to be put inside your alkali because it will be pink. So from pink it changes to colorless. Okay, and then here you have your flask, conical flask. All right, so that's it. Okay. All right, can I have the next question? Ooh, okay. So, from Alice Wong, diagram 6.1 shows a structure X and Y that represents two molecules of two common cleaning agents. Okay, now, if you were a student taking for this exam, all you would see was carbon, 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 carbon. All right, that's all you would see, and then you would get a shock. So all you need to see for X is X goes on and on and on and on and on and on and on. If you look at the question, it just goes on and on and on, and then it ends with this, and you don't really need to bother about the benzene ring as well. All you need to look at is this. If it has a sulfate or a sulfonate like this, it comes from detergent. Okay, now the other one, the other question, the other structure Y, it also goes carbon, 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 carbon. It goes on and on and on and on and on and on. You also don't need to bother about that. It just ends with C, O, O, and A. Okay, this part is soap. That's it. Okay, so name the cleaning agent for structure X, detergent. Y is soap. Water soluble part. Okay, water soluble part is the ionic part. So the ionic part is here. It's the same for both. Okay, all right. So you don't need to go and memorize this CH3, CH2, CH3, CH2 in the question. You just need to know whenever you see a very long chain and it ends with a SOO, it is detergent. If you see a very long chain, it ends with a COOO or Na, it's a soap. Okay, because soap is made from fatty acids. That is a type of carboxylic acid, and detergent is made from sulfuric acid. That's why they have the S there. Okay, so can I have the next question, please? Which elements dissolve in water produce solutions that turn blue litmus paper to red and then decolorizes? Oh, you don't even need to think, it's just chlorine. Okay, so chlorine is a bleach. So 1. And bromine can also be used. Okay, iodine not really. So the answer is A, 1 and 2. Bromine and chlorine. Because astatine and iodine, they are too heavy already. Okay, so okay, glacial. Can you so when you see this question, this is question from Ellen. The most important part of this question is glacial. Glacial means no water. Okay, the word glacial here means no water. Or so glacial ethanol acid is put into 4 test tubes A, B, C, D. Which one will a reaction occur? So the only reaction will occur when that glacial ethanol acid has something that has water in it. Okay, so you see the first one is pH paper, no water. Second one is calcium carbonate chips, no water. It's a solid, right? Magnesium ribbon is also no water. So the answer is D, because you have sodium carbonate solution. Solution has water, so it brings its water and therefore it can have an acid reaction. The acid will dissolve in this water. So the answer is D. Okay? Can I have the next question? Digital communication plays very important. Okay. Voice, images, and digital format require suitable material. So this one is optic fiber, C. Isn't this a physics question though? All right, so digital voices, everything is optic fiber. It can't be superconductor, silicon or copper. Okay, so the answer is C. Next question. Okay. All right, so while we're waiting for questions, let's talk about colors. Because I think just now that question, she was trying to ask about different kinds of colors, about salt testing, I guess. Okay, so first of all, testing that has color is only 3 ions that have color, which is iron 2, iron 3, and copper 2. Okay, so this one is green. This one is brown. Okay, this one is blue. But it's only blue sometimes, okay? It's blue when it's in copper sulfate. It's blue when it's copper chloride. It's blue when it's copper nitrate. All right? In copper carbonate, it's green. And for copper oxide, it's black. All right? But when we test for it, we use sodium hydroxide. When we test for sodium hydroxide, we have to change it to a solution. Okay? Meaning, iron 2 can only be tested in a solution, iron 2 chloride. So you add the sodium hydroxide inside and you will see a green precipitate. Okay? If it's iron 3, you add sodium hydroxide also, you see a brown precipitate. All right? Now, if you're testing for copper, for example, copper sulfate, copper chloride, copper nitrate. So you have to remember, these all have to be in aqueous solutions. Okay? They all have to be in aqueous solutions. So you add sodium hydroxide. This one will have a blue precipitate. Okay, now if you're talking about using oxidizing agent, then that's different. So oxidizing agent is acidified potassium manganate 7. So that changes color when it has been reduced. So for example, acidified potassium manganate 7 is purple. Okay, this one is an oxidizing agent. Means it will oxidize somebody else. So who likes to be oxidized? So you can add potassium bromide, which is colorless, or potassium iodide. Okay, the iodide becomes iodine. The potassium manganate changes from purple to colorless. Okay, so that's one color test. Okay, another color test is using organic solvent. For example, when we are using bromine water to test for alkenes, so you add bromine water, it will change from brown to colorless. So this is only for alkenes. Okay, so these are the few color tests. All right. Okay, next question from Faiz. Jadual 3 menunjukkan maklumat bagi 3 jenis ubat yang berbeza. Analgesic for pain, penicillin. So Q, penicillin is an antibiotic. And chlorpromazine for psychiatric illness is a psychotherapeutic. Okay, psychotherapeutic medicine. All right, name of medicine P. All right, to relieve pain without causing numbness. So you can say anything from paracetamol, because causing numbness is a strong analgesic. This one is just a mild analgesic. One of the medicines must be finished during the course of treatment. Which one? So ubat yang mesti dihabiskan is antibiotic Q. Okay, can? So one effect if the patient does not complete the medicine. Okay, if the patient doesn't finish the medicine, the bacteria becomes resistant to antibiotics. Okay, so jika tak habiskan ubat antibiotik, bakteria akan jadi resistant. Lain kali jika kamu makan ubat yang sama untuk bakteria yang sama, jangkitan bakteria yang sama, tak akan berjaya untuk membunuh bakteria. You don't get to kill the bacteria a second time using the same antibiotics again. Over a period of time, the bacteria actually becomes resistant. So nowadays we already have bacteria yang sudah resistant. You cannot kill it already. Okay, can I have the next question? All right, so a lab assistant wants to prepare calcium sulfate. Okay, so the question gives you calcium nitrate and sodium sulfate. You get calcium sulfate and sodium nitrate. Calculate the mass of calcium sulfate. How much of this you get when 50 centimeter cube of calcium nitrate 0.1 mole per decimeter cube is added to 50 centimeter cube of this, 0.1 centimeter cube. Okay? All right, so the first thing you need to do is calculate the amount of moles. So the moles of calcium nitrate and the moles of sodium sulfate are the same. The amount given is the same. The ratio is also the same, so it doesn't really matter which one you count. So you can say you're counting calcium nitrate or you're counting sodium sulfate, same thing. So M V over 1000. So 0.005 mole. Okay? Now, what happens is they're asking you to count the mass. Jisim calcium sulfate yang terbentuk. Okay? How much of this? So first, you need to calculate the molar mass of calcium sulfate. Calcium is 40, sulfur 32, oxygen 64, 16 times 4. So 16 times 4 plus 32 plus 40, so you get 136. Okay, so the relative molecular mass of calcium sulfate is 136. So you take 0.01. So you want to find the mass of calcium sulfate. You take the amount of moles times 136 molar mass. So you get 0.68 gram. Okay, so you must remember step 1, step 2, step 3. Okay, the ratio of calcium nitrate to the ratio of calcium sulfate is 1 to 1. All right, okay, can I have the next question? Okay, a factory manager found that 5,000 centimeter cube of ammonia. Wow, that's a lot. So remember the keyword here is ammonia gas. Okay, has completely reacted with carbon dioxide to produce urea and water. All right. So determine the mass of urea formed in room temperature. Okay, so first you calculate the moles of ammonia. So it's volume over molar volume. But this one is centimeter cube, so you need to change it to decimeter cube. So 5 centimeter cube, okay, 5 centimeter cube is 5,000 centimeter cube is 5 decimeter cube. So you take 5 over 24. Okay, so this one is volume over molar volume. Okay, so I found that a lot of students don't change it. Okay, a lot of students don't change this to decimeter cube. All right, so you get 5 over 24, 0.21 mole. Okay, now what happens is this ammonia gas reacts with carbon dioxide. Okay, it produces urea and water. So urea is actually CO bracket NH2 bracket 2. Okay, so you need to balance the equation first. So here is 3. Here there's 4 and 2. So 6. So you put 2. Okay? And here you got 2 ammonia, 1 carbon, 2 oxygen, 2 oxygen. Okay? So the ratio is 2, 1, 1, 1. Okay? So make sure you balance your equation. 2 nitrogen, 4 plus 2, 6. 3 times 2, 6. Okay? CO, CO, here 1 oxygen, CO2. Alright? I lost my question. The screen gone blank. Yeah. Okay, so we want to calculate the mass of urea. Okay, so this one is 0.21. So the ratio is 2 to 1. So the moles of urea is 0.21 divided by 2. Okay. Mm. 0.105 mole. Okay, now urea is molar mass of urea, CO and H2 bracket 2. So you get carbon 12 plus oxygen 16 plus 14 times 2 plus 4. So urea is 60. So the mass of urea is 0.105 times 60. So you get 6.3 grams. Okay? Can? So, yeah. So it's a question you have to write down the equation. All right? Okay, can I have the next question? Oh, okay. Was that question the second question, is it? You should have showed me this one first. Okay, diagram 7 shows the material used to produce urea. Okay, so ammonia and carbon dioxide. So balance equation there. Okay, so qualitative and quantitative. All right, so qualitative means you write down ammonia plus carbon dioxide forms urea plus water. And then quantitative means 2 moles of urea reacts with 1 mole of carbon dioxide, forms 1 mole of urea and 1 mole of water. Okay, so that's what it means. For every 1 mole, you found 1 mole, 1 mole, 1 mole. Qualitative means what it is. All right, so you write, like, for example, ammonia gas, carbon dioxide gas, urea solid, and then water liquid. Okay, so this is the equation already. Can I have the next question? Oh. Do you want me to answer all? Okay, question 8. Diagram 8 shows the information of 3 sets of experiments. Oh, this is rate of reaction. So the time needed for it to collect 40 centimeter cube of hydrogen. So the first experiment you use 25 centimeter cube of sulfuric acid. Okay, with excess zinc. Okay, so it takes you 33 seconds. Okay, second experiment is 25 centimeter cube of sulfuric acid. It's also 0.2 mole. Okay. But this one, you are using 45 seconds. Okay, this one is using zinc powder. The second one is using zinc granules. Okay, now the third one is also at same amount acid, 0.2 mole per decimeter cube. Okay, and zinc powder. All right, the difference is this time you are adding copper 2 sulfate. Okay, even if you don't know copper 2 sulfate is the catalyst, you have to think logically. What else can it be? Of course, it's a catalyst. Okay, it can't be anything else, right? So this one is definitely a catalyst. And they also give you a clue. Okay, they give you a clue down there. They show you that the reaction path is different for set 3 because set 3 uses a catalyst. So draw energy level diagram as in diagram 8, then show a label curve for set 1 and set 3. So basically, so you draw the same thing lah. You draw sulfuric acid plus zinc. Okay, but not enough place here. Let me make it bigger. Okay, so here you put sulfuric acid and zinc, and here you get zinc sulfate and hydrogen. Okay, so set 1 is without a catalyst, and set 2 is with a, set 3 is with a catalyst. Okay, and label the activation energy for set 1 as EA and set 2 as EA1. Okay, so this is the activation energy for 1. So it would be EA. And the activation energy for 3 would be here. And you're supposed to label it EA dash. Right? Okay, like that you get 4 marks. So easy. So nice, right? Just draw something. And they even give you an example. That's so fun. Okay, so write a balanced chemical equation for the reaction and calculate the average rate of reaction for set 1 and set 2. So balance, wow, this is a really easy question. So A, okay, it's so nice. So write a balanced equation. Sulfuric acid and zinc, zinc sulfate and hydrogen. Okay, so rate for experiment 1 and for experiment 3. Oh no, 2. Okay, so rate for 1 is 40 centimeter cube over 33 seconds. And the rate for 2 is 40 centimeter cube over 45 seconds. All right. So 1.21 centimeter cube per second. Please remember to write the unit. 40 over 45, 0.89 centimeter cube per second. So experiment 2 is slower. Okay, let me check again. Write a balanced chemical equation, calculate the average reaction, and on the same axis, sketch a graph. Oh, okay. So you're supposed to sketch a graph. So it's very little work for full marks. Okay, you don't really have to do anything complicated. You just have to follow the question. So sketch a graph. Okay, so here you put volume. Still have to write the unit. Centimeter cube. And here you put time. Seconds. Okay. all three reach 40. How do you know? It's given in the question. Okay. The difference is experiment 3 is the fastest. Label it 3. The second fastest is experiment 1. And the slowest is experiment 2. Okay, now you don't have to draw this line up here. You can if you want to, doesn't really make a difference as long as it ends at 40 centimeter cube. Okay, all right, finally question C. Okay, question C is my favorite because it's 10 marks, but it's so easy to write. Okay, so basically you have to compare set 1 and set 2 and then set 1 and set 3, and each part is 5 marks and it's the same thing. You always talk about the same thing. So for 10 marks, you're supposed to talk about compare 1 and 2, and for another 5 marks, you compare 1 and 3. Okay, so 1 and 2, you just have to see whose rate is higher. So the rate of reaction for 1 and 2, for 1 is higher than 2. That's 1 mark. The other mark is why. Why is it higher? So 1 uses zinc powder. Okay, 2 is zinc pieces. I mean, you don't have to write it down. So zinc powder, it has a larger surface area. So smaller particle size. That's your second mark. So smaller particle size, larger total surface area. Okay, and then more collision frequency. And then finally, higher effective collision frequency. Higher or more collision frequency and higher effective collision frequency. 5 marks. So you just repeat the same thing for experiment 1 and 3. Okay? So the rate of experiment 3 is higher than 1. Okay, and then why? 3 uses a catalyst. That's your keyword. And then catalyst lowers activation energy, and then you can talk about a pathway using less energy. So it prepares an alternative pathway for the reaction to occur. Now, in this case, the collision frequency doesn't increase, but the effective collision frequency increases. So you just repeat the same point again. So just like that, you get 10 marks. Okay? So if there is a question on rate of reaction, please do this question. It's really, 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 really easy to do. Okay? It's very, very simple and it's always straightforward. It's always the same thing. Okay? All right. Can I have the next question, please? Teacher, can you please explain to me? Oh, isomers of molecular formulas of carboxylic acid. Okay. Hold on. Let me increase the... All right. Yeah. Oh no. Okay. All right. So carboxylic acid. Carboxylic. Okay. Here's the cool thing about carboxylic acid. The isomers for them can be an acid, can also be an ester, except for methanoic acid and ethanoic acid. So acids, the first one is methanoic acid, right? So methanoic acid got no isomer lah, okay? Ethanoic acid also not. You can have an isomer of methyl methanoate, okay? But we'll talk about that's really too small, very hard to talk about it. We'll talk about that in a while. Okay, so methanoic acid don't have. Ethanoic acid, there is one ester. We'll talk about that in a bit. Let's try something simpler. Okay, let's try propanoic acid. So everybody knows propanoic acid is C2H5COOH. Okay, let's draw it out. C2H5 COOH. Okay, now let's do a longer one. Okay, I'll come back to this in a while. So butanoic acid is C3H7COOH. So C3H7COOH. Okay. Now, what happens here is you can actually change this to a methyl if you want. You can take the 3 carbons here and put this here. So, right, it is still 4 carbons, except now it's a methyl. But you must understand that your COOH must always be at the side. So it's always the first carbon. So it's 2-methyl, okay, 2-methyl propanoic acid. That's one way of making it an ester, making it an isomer. All right. Now, however, if it's propanoic acid like this, you put the carbon on top here, you will still get the same thing. It's still propanoic acid. So what you can do is you can change it to an ester. Basically, propanoic acid has 3 carbons, right? An ester is made from an acid and alcohol. So you just split it into 2 molecules. An alcohol with 2 carbons and an acid with 1 carbon. Okay? So alcohol with 2 carbon is ethanol. Acid with 1 carbon is methanoic acid. So the isomer will be ethyl methanoate. How will it look like? HCOO C2H5. So it will look like this. HCOO C2H5. Okay? Now, you count and see, does it also have 3 carbons? 1, 2, 3. 1, 2, 3. Does it also have 6 hydrogens? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Does it have 2 oxygen? 2 oxygen. Okay? Can you think of another isomer? You can change it to methyl ethanoate. You will have the same thing. Okay? So methyl ethanoate is CH3COO CH3. You count and see, you will have the same amount of carbons, hydrogens, oxygen. So isomer for carboxylic acid, there are few ways you can do it. One way is but it has to be a long chain hydrocarbon. You just put change it into a methyl, but it has to be long enough chain. Or you can change it into an ester. So like for example, butanoic acid, you can change it to 2-methyl propanoic acid, or you can change it around and become ethyl ethanoate, Okay, ethyl ethanoate is also an isomer of butanoic acid. Okay, so you can go around and play around with it. You will realize that if you make an ester with the equal amount of carbons as the carboxylic acid, they are isomers to each other. Okay, all right, next question, please. Qualitative garam. Okay, analysis qualitative for garam. Okay, so semua garam. There's a lot. So garam yang ion positif. Okay, ion positif kita bagikan kepada yang ada warna dan yang tak warna lah. Okay, yang ada warna ferrum 2, ferrum 3, copper 2, cuprum 2 saja. So kita gunakan sodium hydroksida. Ini akan jadi mendakan hijau. Ini jadi mendakan perak. Ini jadi mendakan biru. Itu saja. Okey. Yang tak berwarna ada ion kalsium, magnesium, aluminium, zinc, plumbum dan amonium. Okey. Maksud kita kata uji ialah apabila dalam tabung uji dia ada larutan, kita hendak uji apakah ion yang di dalam dia. So contohnya sekiranya dia ada cuprum 2 sulfat, larutan aqueous cuprum 2 sulfat, kita tahu bahawa di dalamnya ada ion cuprum, ada ion sulfat yang mana akan yang nak kita ujikan. So katakan nak uji kehadiran ion cuprum 2, so kita tambahkan sodium hydroksida, dia akan jadi mendakan biru. Sekiranya ada mendakan biru, kita tahu bahawa ada ion cuprum. Itu maksudnya. Untuk ion amonium, kita tak tahu tabung uji ada amonium ke tidak, tapi kita tambah sodium hydroksida, dia tak ada warna, tak ada mendakan langsung, tetapi kita panaskan, dia akan keluar gas amonia. Okey. Now, untuk yang 5 yang lain, untuk uji kehadiran ion kalsium, ion magnesium, ion aluminium, zinc atau plumbum, kita tambah sodium hydroksida. Semuanya ini sama je. Dia akan jadi mendakan putih. So apa berlaku ialah kepada tabung uji yang sama, kita tambah sodium hydroksida yang lebih. Kali pertama kita tambah beberapa titik, kemudian kita tambahkan titisan yang lebih. So kemudian sekiranya dia kalsium atau magnesium, mendakan putih itu masih hadir. Sekiranya dia zinc, aluminium atau lead, mendakan putih itu akan larut. So selepas itu kita buat ujian yang kedua. Kita ambil satu tabung uji yang baru dengan ion kalsium, magnesium, aluminium kita tak tahu. Sekarang kita tambahkan larutan amonia untuk uji. Okey? So sekiranya langsung tak ada mendakan, dia merupakan ion kalsium. Sekiranya dia ada mendakan putih, dia ialah magnesium, aluminium, zinc atau plumbum. Kita tambah beberapa titis amonia, keluar mendakan putih. Magnesium, aluminium, zinc atau plumbum. Kita tambah lebih, hanya satu mendakan putih dia larut semula, iaitu ion zinc. Okey? So itu cara kita nak uji untuk ion positif. Panggil analisis kualitatif. Okey? Kemudian kita juga boleh uji kehadiran ion negatif atau cation. Anion. Okey, so anion yang kita uji, ion karbonat, ion sulfat, ion nitrat, ion klorida. Okey, untuk karbonat senang saja, tambah asid. Apabila tambah asid, dia akan keluar gas karbon dioksida gas karbon dioksida boleh diuji dengan air kapur. Okey. So, kemudian soalan tak tanya sila uji karbonat, sila uji. Soalan tanya macam ni. Sini ada satu garam. Garam ini kuprum karbonat. Saya nak kamu uji kehadiran ion kuprum dan ion karbonat. So, apa kamu buat? Kamu letakkan dia dalam tabung uji. Kamu tambahkan asid. Kemudian, kuprum karbonat akan, contohnya kamu tambah asid sulfurik. Dia akan jadi ion kuprum sulfat dan karbon dioksida dan air. So, dia akan bebaskan karbon dioksida. So, kamu uji gas yang dibebaskan. Ini menunjukkan bahawa ini ada ion karbonat. Kemudian, kamu ambil kuprum sulfat itu yang kamu sudah bentuk, tambahkan sodium natrium hidroksida, dia akan jadi mendakan biru. Itu maksudnya ada ion kuprum. So, soalan tak akan tanya, oh ini buktikan ada karbonat, buktikan ada ferrum 2. Tak. Dia akan tanya, di sini ada contohnya, larutan ini ialah ferrum 2 klorida. Buktikan kepada saya ada cation dan anion. Apa cation dan anion? Buktikan ada ion ferrum 2, buktikan ada ion klorida. Untuk ion ferrum 2, tambahkan sodium hidroksida, dia jadi mendakan hijau. Untuk klorida, sekarang kita bincangkan. Untuk klorida, tambah asid nitrik, kemudian tambah argentum nitrat. Kamu tambah dua-dua ke dalam sini, sekiranya ada klorida, dia akan jadi mendakan putih. Okey? Okey. Sama juga. Sekiranya soalan tanya, okey, buktikan kepada saya ini mempunyai cation dan anion zinc dan sulfat. So, macam mana uji zinc? Tadi kita baru bincang. Tambahkan sodium hidroksida secara berlebihan, larutan putih akan larut semula, atau tambahkan larutan amonia. Actually, tambah amonia lebih baiklah. Satu ujian saja. Tambahkan amonia secara berlebihan, mendakan putih, terbentuk, kemudian larut. Macam mana nak uji kehadiran sulfat? So, senang saja. Tambahkan asid nitrik, tambahkan barium nitrat. Okey? Akan jadi mendakan putih. Okey? Kan? Alright. So, akhirnya nitrat. Nitrat kita guna ujian cincin perang. Okey? Ujian cincin perang. So, ujian cincin perang, apa yang kamu nampak? Cincin perang lah. Tapi cincin perang tu maksudnya dalam gelang, dalam asid, dalam larutan dia akan jadi satu gelang perang di dalamnya. So, apa yang kamu tambah untuk ujian nitrat? Tambah asid sulfurik cair, ferrum 2 sulfat, kemudian asid sulfurik pekat. Apabila kamu tambah, nampak cincin perang, itu ialah nitrat. So, soalan tak akan tanya, buktikan nitrat, buktikan sulfat. Dia akan berikan kamu satu larutan, ada cation, ada anion, dia suruh kamu buktikan kehadiran anion dan cation ini. Okey? Okay. Soalan berikutnya. Okey, Afiq Rizal. Okey. Okey, soalan ini dia kata 9.26 gram R bertindak balas dengan 8.2 gram oxygen gas. Which of the following represents the chemical equation for this reaction? Okay, first thing is first. Do they give you anything? Soalan ada bagi jisim atom relatif bagi oksigen dan R. Ada lagi tak dalam soalan ini? Jika tak boleh, sebab tak boleh buat apa-apa. Kecuali kamu tengok yang persamaan mana yang balance. 3R. Okay, you can't do this question. You have to have what is R. Okay, atau so Afiq, tolong lihat lagi, adakah soalan bagi kamu Jisim atom relative untuk R? Jika tak, langsung tak boleh buat. Okay, sebab kamu boleh kira oksigen, boleh ambil 8.2 bahagi 32, tapi ini tak beri kamu apa-apa tentang R. Mesti bagi kamu apakah jisim atomic relative. Jika bagi kamu jisim atomic relative, kita boleh buat soalan dia. So, tolong cek semula soalan ini. Jika tak ada masalah dengan soalan. Okay? Main topic to score well in paper 2. Here's the thing. Setiap topik akan tanya sekurang-kurangnya satu soalan. Kamu hanya ada 10 topik dan ada 11 lah, 11, 12. Topik yang kecil-kecil tak payahlah. Okey, tapi dia akan tanya satu soalan sebatian karbon, satu soalan ikatan kimia, satu soalan tentang kadar tindak balas, satu soalan tentang elektrolisis, satu soalan tentang redox, satu soalan tentang thermokimia. So every chapter they have one question. So main topic to score well. Every topic, make sure you can. The best thing to do now is to do your past year papers and see. Hey, every topic comes up once. I've never seen a past year paper where only the Form 4 topic or only 5 topics out of 10 come out. It's impossible. So every topic you need to know how to do the question. Okay? All right. Next question. Help me draw molecular structure polymerization of organic compound. Okay. So polymerization that you study, pempolimeran, you only study polymerization of alkene. Okay? Kamu hanya belajar tentang pempolimeran alkene sahaja. So kita ambil contoh etin atau etina. Okay? So pempolimeran maksudnya banyak-banyak etin gabung bersama-sama. Okey, apa berlaku ialah di sini karbon-karbon molekul ini akan gabung. So, gabung macam tu. Tetapi satu karbon hanya boleh ada 4 ikatan, can only have 4 bonds. But now it has 5 bonds. 1, 2, 3, 4, 5. So you take out 1, daripada 2 jadi 1. Daripada 2 jadi 1. Daripada 2 jadi 1. Okay? So this is polyethene. Alright, so it's very easy. Okay. So if it's like this, all you need to do is cari ikatan tubel, find the double bond, open up, and then ulang. Repeat like that. Or you can draw like that. And okay. Now, ada kala dia suruh kamu lukis pempolimeran propina. So they ask you to draw polymerization of propene. How? So a lot of students they do propene like that. And then, how teacher? Propene like that or? Okay. So always remember, you find this carbon with the double bond. Okay? And then you make it like that. So here hydrogen you go up. Here hydrogen you go down. Here hydrogen you go up. And then here is CH3, right? So you go down. Okay? Alright, so all you need to do is, again, open up, from 2 bond become 1 bond, and then everybody hold hands. Hold hand, and go on and on. So you can draw it like this, or you can just draw, if you started out like this, right? So you just take this, draw like that, bracket, and okay? Alright, so for anything it's the same. You just make them all, make sure you just find the double bond and then push everybody down or up and to make sure the sides are clear. the sides are clear, then you put whoever you want to put up and down. Okay? Can I have the next question, please? Any more questions? Okay. All right. Diagram 2 shows the apparatus set up to prepare soluble salt. Okay. Which of the following salt is prepared by this method? Oh, you only have to see who is soluble. So the only, okay, look at the first picture. The first picture is titration. Titration must be a sodium, potassium, or ammonium salt only. That's the thing. So the answer is B. Only B can be done by titration. Nobody else. Okay? So that's why you have to choose B. Okay, next question. Haiza, Raja 21 menunjukkan elektron susunan elektron dalam sebatian TZ. Okay? Which element represent by T and Z? Oh, okay. So, kamu lihat sini. T, dia sekarang ada 2, 8. Tapi, dia ialah charge positif 1. So, inilah ion T. So, original ialah 2, 8, 1. Ini natrium lah. And then, bagi Z, sekarang dia charge negatif 1. Dia sekarang 2, 8. So, original tapi dia negatif. So, original ialah 2, 7. So, siapa 7? Fluorine. So, kamu mesti lihat sini. Charge dia juga. So, jawapan dia ialah C. Sodium dan fluorine. Okay. Can I have the next question? Oh. Barbiturat are synthetic drugs used in medicine to depress the central nervous system. The effects are range from mild sedation to coma. They may use as sedatives. Hypnotics are part of anesthesia. Some barbiturats are used to relieve tension or anxiety prior to surgery. As a chemistry student, justify the usage of human. Oh, this one actually you can write anything you want. All right, so you can say for 3 marks, you can say it is good because it helps to relieve tension for people, relieve anxiety. It is good because how is it good? And because it helps before people have to go for surgeries. It helps for people who have pain and things like that. So you say 2 things that is good, and then you can write about how it's bad. So it's bad because it's very dangerous, as in if you have too much of it, you can overdose, could become coma. All right. If they accidentally put too much of it, they can lead to coma, they can lead to death, and also you can talk about how it becomes addictive. All right, so this is a general idea, like how you write about things that are good and write things that are bad. Okay, so you can write a lot of things for this. It's just 3 marks, so don't worry. So you just write about how it's good, as it can be used for pain, for surgery, for this, to relieve anxiety. It's bad because you could have overdose, it could be addictive, it could cause addiction, and it also can lead to coma and death. So you talk about good and bad. Okay? All right. That's an interesting question. Next question, please. Ujian kimia untuk mengesahkan hasil terbentuk di Q. Okay, so kita lihat sini. Electrolysis gunakan larutan kalium klorida. Okay, now. So, they don't tell you whether, tak beritahu sama ada pekat atau cair. Tapi, kamu boleh tahu bahawa di sini 1.0 mol per decimeter cube merupakan larutan pekat. So, sekiranya larutan pekat, ion di anode ada 2 jenis, klorida dan hidroksida. Dalam larutan pekat, klorida akan dinyacaskan dan klorida akan jadi gas klorin. Okey, so macam mana nak uji guna ujian kimia? Kamu guna kertas litmus biru yang lembap. Dia akan jadi merah, kemudian akan jadi putih. Okey, itu saja. Very easy. Alright. Sekiranya gas yang terbentuk di cathode, ion dia ialah ion hidrogen dan ion helium. Tapi ion helium tidak akan dinyacaskan. Ion hidrogen dinyacaskan menjadi gas hidrogen. Ini ialah kayu uji bernyala akan mempunyai bunyi pop. Okay? Alright. Can I have the next question? Oh, a group of students were given a apparatus and chemical listed. Okay, so kamu diberi. Okay, so sekiranya soalan berbagi begitu banyak bahan, kamu boleh gunakan bahan yang lain. Tak boleh. Okay, so kamu diberi beaker, wayar, voltmeter. Kamu diberi larutan natrium nitrat. Kamu diberi electrode zinc, electrode copper dan magnesium. Okey. Lukiskan gambar raja berlabel untuk menunjukkan penghasilan tenaga elektrik daripada tenaga kimia yang dihasilkan. Draw a label diagram to show the formation of electrolyte from. Okay, who is the highest one? The highest one will be the furthest apart. Yang paling jauh dalam siri elektrokimia. Cuprum dan magnesium paling jauh. So, kamu kena lukis cantik-cantik. Magnesium. Cuprum. Aqueous, natrium nitrat. Okay. Label cantik-cantik lah. Kepingan, voltmeter, beaker, all that. Okay? Alright. That's it. Can I have an next question? Okay. Full calculation. Okay, don't worry. Let's do the full calculation. Alright. Empirical, okay, 10 markah. Oh, banyaknya soalan dia. Okay. Compound consists of 85.7% of carbon dioxide. Okay, let's draw nicely. Okay, let's draw a table. So you need to draw full calculations. Okay. So, carbon, hydrogen. So first let's find percentage. It's given 85.71 and 14.29. Then you calculate here amount of moles. So you divide the divide the molar mass. Okay. Okay. Then you find the ratio. Okay, so divide the smallest number. Okay, so empirical formula CH2. Okay, so now you find N. Okay. N is molecular mass over empirical mass. Molecular mass is the one they give you in the question. Molar mass, 70. And then empirical mass is the mass of this empirical formula. 12 plus 2 equal to 14. Okay. So 5. Okay. Then, so molecular formula CH2 times 5, C5H10. Okay, not you finish it. So, determine the empirical formula, draw the structure. Okay, draw the structural formula of 2 isomers of X and write each of the isomers based on the IUPAC nomenclature. Okay, so C5H10 ma, so pentene. So you draw pen 1 in. 1, 2, 3, 4, 5. 1, 2. Okay, can you draw your own hydrogens? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. So this is pent 1 in, and then you just draw pen 2 in. Okay, there, 10 marks already. So you draw your own hydrogen, nice, nice, okay? Exam, you must draw nice and pretty. 1, 2, 3, 4, 5. All right, that's it, 10 marks. Okay, so this is full calculations. Showing the table, showing the n, and showing this is full calculations. So that's half your marks and that's half your marks. I think over here is 6 and here's 4. Okay. Can I have the next question? Okay. What substances can be used as electrodes to obtain the brightest light? So you must find the one furthest apart from the electrochemical series. So it's copper. So who's the furthest from copper? Magnesium. So the answer is A. Okay. All right. So the question on top, the answer is A. The question below, electrolysis of molten aluminium oxide, which are the following half equations show the reaction at the cathode. So for question 4 is B. Okay, because molten aluminium oxide, aluminium ion. So the two answers are A and B. All right. So for this, you just choose the one that is furthest away from copper in the electrochemical series. The one that is the furthest away will always give the brightest light, the highest voltage. That's what I mean by furthest away now. So here's copper. So magnesium is here. So furthest away lah. Okay? Alright, next question please. Oh. Table 1 shows the results of displacement reaction to determine the electrochemical series. Okay? So, arrange in ascending order the tendency of the metals to form ions. Okay, to form ions means the most reactive. So ascending means from the least to the most. All right. The one that there is a reaction with everybody is the most reactive. Okay? So the one that says that displaces everybody. Copper is displaced, lead is displaced, zinc is displaced, so X. Okay? The one that can displace everybody. So the X is the most reactive. So the least reactive is the one that cannot displace everybody. So W lah. No change, no change, no change. Okay. So in the middle, Y and Z. Who's in the middle? So Y displaces copper and lead, but no change with magnesium. Z can only displace copper. So Z is next to copper, and here is Y. Okay? So W, Z, Y, X. The answer is A. You find the one that can displace the most. Okay, the one who can displace everybody else is the most reactive. The one that to form ions. Okay? Can I have the next question, please? Oh. Okay, so this one is electrolytic circuit using inert electrodes. Okay, so which electrodes are group 17 elements produced? So, okay, let's see here. So here's H. H must be negative. Okay. Here's E. E must be positive. All right. So if E is positive, F must be negative. Then only G can be positive. Correct? Okay. So this one is bromide. Will go here to form bromine. This one is chloride. Will go here to form chlorine. So the answer is E and G. A. Oh, all my answers are A today. So you all get A in SPM. Okay? All right. Next question, please. Okay, here's another calculation question. All right. The following question represents the combustion of methane. Calculate the volume of carbon dioxide if 3.2 grams of methane is used. So first thing you do is find the amount of moles of methane. So you take mass over molar mass. Carbon is 12, hydrogen is 1 times 4. Okay, so this should give you 0.5, right? 3.2 divided 16. Okay, 0.2. Okay, so 0.2 mole. And then, so how much volume of carbon dioxide is formed? So the ratio of methane to carbon dioxide you see in the question is 1 to 1. So if this one is 0.2 mole, this one is 0.2, you take 0.2 times 24, you get 4.8. Oh, they give you 22.4, sorry. 22.4. So you get 4.48. That's it. A. Again, the answer is A. All my questions today, the answer is A. That's a good sign. All right. So the answer is A. You just take the amount of moles. The ratio is 1 to 1 times molar volume. Okay. The question already gave you 22.4, so you must use 22.4. All right. Okay. Next question, please. Okay. Another calculation. Wow, you guys are on a roll. Peratus mengikut jisim bagi setiap unsur di dalam satu sebatian juga jisim atom masing-masing. Okay. Formula empiric. So you take carbon 26.7 divide 12. Hydrogen 2.2 divide 1. Oxygen 71.1 divide 16. Okay, so okay, so this is quite obvious, right? Okay, so you divide the smallest number, divide 2.2, 2.2, 2.2, so you get 1, 1, 2. So the answer is, oh, this time is B. Okay, C, H, O2. Okay, B. Can I have the next question? All right. Another calculation. Empirical formula and molecular formula. Oh, okay. Based on the information, compare and differentiate between empirical formula and molecular formula of ethene in terms of type of element, number of atom, and relative molecular mass. Okay? So, okay, these kind of questions, right? Always do it like this. Okay? So, the type of element for both is the same. Okay? The number of atoms for each element. Okay? So number of atom for carbon, okay, so for the molecular formula is double of the empirical formula. It's just times 2 what? And then one more, the relative molecular mass. So the relative mass is also doubled. Okay, so 3 marks. They're just asking you to differentiate. All right, next question. Food technologies. Because potatoes use radioactive, what following is suitable to be used? Oh, okay. Okay, we usually use sodium 24 for pipe leaks, carbon 14 for carbon dating, cobalt 60 for treatment of cancer. So phosphorus 32 is to kill bacteria. Okay, so the answer is C. Next question, please. Oh, okay. So, okay, the thing about the, okay, let's count this again. Okay, so the thing about the calculation, okay, okay, so the thing about the calculation, okay, so let's try and count. Okay, so if it's the relative mass, okay, if it's the relative mass, they always ask you for the n. Some we don't understand. Okay, let me count it up for you. Okay, so for example, just now was CH2 and C2H4. So the n is basically this thing, which is 24 plus 4, 28 over this one, CH2, 14, so 2. So that's what the double comes from. So you just have to take CH2 times 2. You get C2H4, like that. Okay, can? All right, now let's look back at just now we didn't have time to do the isomer for ethanoic acid because it would be really complicated. Okay, so the isomer for ethanoic acid, so it's CH3COOH. So actually, if you want to do it into your ester, you can just use methyl methanoate. Okay, HCOO CH3. Okay, so it will look like this. HCOO CH3. So you count and see 2 carbon, C2, H4O2 is the same. Okay, so ester is isomer also for carboxylic acid, but in those long carboxylic acids, for example, pentanoic acid. Okay, you must always remember your COOH must always be at the last carbon. Okay? Alright. And then this, you want to make it to isomer, what you do is you still must maintain the COOH. It's just that your carbon, you can make it into a methyl. Like this, for example. Okay, so 1 is still 1. Oh, 1, 2, 3, 4, 5. But what you do is you put one here. So this will be called, your first carbon is always your carbon next to the COO. So 1, 2. Okay, so 3-methyl butanoic acid and pentanoic acid are isomers of each other. So this one also, you can change it to ester to make an isomer. You can do ethyl propanoate, okay, or propyl ethanoate, or methyl butanoate, or butyl methanoate. So you have so many isomers that you can make. Now, let's, for example, they ask you to test, okay, for magnesium. They give you a solid to test. Okay? Or they don't tell you solid lah. They just tell you is magnesium carbonate. Okay? And they're asking you to test the presence of it. Now, you always have to test the carbonate first. You cannot test the magnesium first. Magnesium must be tested in the form of an ion. In a solid, the ions are not moving, so you cannot test it like that. So whatever it is, you must always dissolve in acid first. Okay? So after you dissolve in acid, so this diagram you must be able to draw. Okay, where you put the carbonate. Okay, so here you put lime water. All right, so this dissolves the magnesium carbonate in acid and causes it to become magnesium ion. Okay, so in magnesium chloride is an aqueous solution, so it's a magnesium ion. All right, so the carbon dioxide that is released causes it to become, lime water becomes cloudy. So you prove that it is carbon dioxide, so you prove that it's carbonate. Okay, how do you test for this magnesium? So you take the aqueous solution that's left over. Okay, so you test it with sodium hydroxide, and then you have to test it with ammonia, aqueous ammonia. You have to do 2 experiments. Why? Because this one gives you white precipitate that doesn't dissolve, but it could be calcium or magnesium. Then you do this one, it gives you a white precipitate. Okay, so it gives you a white precipitate that doesn't dissolve for both sodium hydroxide and ammonia. Then it's a magnesium ion. Okay. Okay, now for electrolysis, right? Okay, for electrolysis, remember if they're using 2 different electrodes, okay, so for example, using carbon, like the first one we did just now, and using copper. So remember the color changes. This one, okay, so this one, the color changes. It changes from blue, and then it will become, the intensity will decrease, and eventually it will become colorless. Okay, that's because the copper ion is discharged at the cathode. The copper ion is the one that makes it blue. Okay, so if there is less and less copper ions, it will be less and less blue. But on the anode side, hydroxide ions are discharged, and that gives you just oxygen. But on this side, the copper ion becomes copper. Okay, over here, copper becomes copper ion. So for every copper ion that is removed, there is a copper ion that is ionized into the solution. So this one, the blue, stays the same. Okay? So this is an example of a question they ask you. Okay, now one more question, calculation. Okay, let's count it out. So if they give you, let's say, 6.02 times 2. Okay, let's say they give you 1.204 times 10 to the power of 24 particles. Okay, now when you see something like that, always divide it with Avogadro's constant. Okay, then you will get your amount of moles. Okay, can? All right, now the differentiation of organic compounds, for example, alkane and alkene. Okay, so this one is easy. The easiest thing to do is just use bromine water. Okay, this one doesn't change, stays brown. This one, brown to colorless. Okay, however, so this is a very common question. Alkane can differentiate very easy. However, if they ask you to differentiate between alcohol and carboxylic acid, then how? Let's say they give you ethanol and ethanoic acid. Okay, now one easiest thing is a lot of students say, oh, just add pH meter or universal indicator. Ethanol will give no color change, or it will become green. Ethanoic acid will change to, let's say, yellow or orange. Okay, but you cannot do that because sometimes the question says without using an indicator. Okay, you don't use an indicator. So in that case, you have to do what I showed you just now. You add a carbonate. You add calcium carbonate. This one will have carbon dioxide. So it will show bubbles, carbon dioxide bubbles that will turn lime water cloudy. And this one, you add calcium carbonate, no changes. Okay, so you have to understand the differences. All right, now if they ask you to compare alcohol with alkene, then how? You can still use bromine water. You can still use bromine water. Alkene will have a reaction, alcohol will have no reaction. Okay? All right. Okay, last question that we're going to answer today. Table 2 shows the melting point and boiling point of substance M. Okay? Okay. So this kind of question, melting point, 78 degrees Celsius, and boiling point, 221 degrees Celsius. Okay, so let's do so they're asking what is the physical state of substance M at 100 degrees Celsius. Always when you get this kind of question, you do this. So this is 100 degrees Celsius. Okay, 78 is over here. So it melts at 78. So that means before 78 it's solid, after 78 it's liquid. And it will stay liquid until it reaches 221, which is the boiling point. So after 221, it will become gas, right? So the question is asking, at 100 degrees Celsius, it's liquid. Okay, so the answer is B. Is there another question? Okay. What important thing should I know about soap and detergent? Soap made from fat and alkali. Okay. Detergent made from petroleum and sulfuric acid. Okay. This one is biodegradable. So no pollution. This one non-biodegradable, so pollution. But soap cannot use in acid, cannot use in hard water. Hard water is not air keras, air liat. Why cannot? Air liat is air yang ada ion calcium, ion magnesium. So the calcium or magnesium will stick onto the soap ions and then make it insoluble in water. So the calcium ion and magnesium ion is found in hard water. So tak boleh pakai. But then detergent can react, can work in acid. That means the larutan yang ada acid, sikit acid, it can still function. And can still function in hard water. That means got calcium, magnesium, still can function. So the question will ask you, which one is better? So you must answer lah. It's better for the environment is soap. Cleaner is detergent. Okay? So if they ask you why it doesn't work in hard water, you just have to say it is insoluble in hard water. In hard water and acid, it is insoluble, but detergent is soluble in hard water and in acid. Okay? So, but then soap uses renewable resources because it's made from fat or oil ma. Alright, you can use it, you can get it anytime. But detergent is made from petroleum. Petroleum is very precious. Okay, so which one makes the clothes cleaner? Detergent. But nowadays they have soaps that are better. You can use other added things. So it depends. If you're talking about chemistry, what makes the clothes cleaner is detergent because you can have additives. You can add phosphates. But the phosphates in the additives also cause more pollution. It causes eutrophication. So both have their pros and cons. So better for the environment is of course soap. Cleaner to wash is of course detergent. So depends what the question is asking. So the important thing is they ask you why cannot use in hard water. Don't say because cannot use in hard water. Say because it is insoluble in hard water. And then why can use in hard water for detergent? Because it is soluble in hard water. Okay. So make sure you know how to do your ionic compounds, your covalent compounds. Make sure you know how to write the properties, okay, and how they form. Make sure you know how to do electrolysis and all your calculations. Practice your past year papers. Now all the kertas percubaan should be out already. Go online and search for the kertas percubaan and try and do. Okay? Now, a lot of students ask me about paper 3. Look through your the experiment book and just look through those that you can do in your school lab. They're not going to ask you experiments that you cannot do. So things like getah tervalkan and getah tak tervalkan, yang mana lebih kuat, yang mana lebih kenyal, things like that. And then things like acid yang mana lebih pekat. So kajikan kadar tindak balas. Simple experiments like that they will ask you. Okay? Esterification so far and not really very often, but you still need to know how to make ester. Okay, so simple, just remember carboxylic acid and alcohol makes your ester. Okay, all right. So thank you for watching, and don't forget to watch the other recorded sessions of TanyaCikgu and other videos at spmflix.com. So if there was any questions that you couldn't get, you can go and look again. Tomorrow, TanyaCikgu will be live again at 10 a.m. for science and 12:30 for biology. Okay, so bye-bye and good luck. Thank you.